This video goes over the last few examples that we didn't get to today. So here in example C, we need to find a value for the tan of 330, and we also have to find a value for the cos of 135. So I'm going to start with tan 330. I've drawn my quadrant here, and I'm going to label them. And then 330, I know is going to be in my last quadrant. Here, I know that my related acute angle is going to be 360 minus 330. So that gives me my related angle of 30 degrees. Now the next thing that I'm going to find is the tan of 30. So going back to my special triangles, which I've redrawn here, the tan of 30 degrees is opposite over adjacent, which is 1 over root 3. Connecting that to the quadrant that my principal angle is in, I know that tan is negative in that fourth quadrant. So I can say that the tan of 330 degrees is equal to negative the tan of 30 degrees, which means that it's equal to negative 1/3. And so that is my value that I have over here first. So let's do the same thing for cos 135. I will use blue this time. So I'm going to draw my quadrant again and label it. And then I'm going to put in my angle of 135 right here. So this is my angle 135, my principal angle. I'm then going to find my related acute angle. So my related acute angle is 180 degrees minus 135, which is going to give me 45 degrees, which actually matches up with my other special triangle. The next thing that I'm going to do is to evaluate the trig ratio for that related acute angle. So cosine of 45, I know that that's equal to 1 over root 2. Just like for tan 330, I'm going to make the connection between the quadrant that I'm in and the value of my trig ratio. So I'm in the second quadrant, sine is positive there, so then my cosine ratio has to be the same value as cos 45, but negative. So now I've got my second value that I'm going to put in here, negative 1 over root 2. Then I can multiply those values together, so I get 1 over root 6. Rationalizing that is going to give me root 6 over 6. The last two examples here is we're looking for the possible answers of angle theta. So we're going to go through almost the same procedure that we did above. First thing that we're going to do is draw our quadrant, label using the cast rule, and then I'm going to figure out the possible quadrants that my angle can be in. So my sine ratio is negative, so I could be in the third quadrant or I could be in the fourth quadrant. So the next thing that I need to do is I'm going to find my related acute angle, which means I'm going to do the inverse sine of the positive value that I have here. Now, what I know is I'm going to go back for a minute here, going back to my triangle here. I know that the sine of 45 degrees is 1 over root 2, which means that my related acute angle here has to be 45 degrees. That means I've got 45 degrees here and 45 degrees here, which is going to allow me to find my two possible principal angles. So in quadrant 3, I've got my theta is 180 plus 45, which is going to give me 225. And then in quad 4, I've got theta equals 360 minus 45, which is going to give me 315 degrees as my second angle. The last example that we'll do here is tan theta. So just like in A, I am going to figure out where the tan ratio is negative It's negative in the second quadrant and in the fourth quadrant. Next thing that I'm going to do is look for my related acute angle. So my related acute angle, I'm going to do the tan inverse of the positive value here. You should recognize that root 3 as a ratio in one of our triangles. So right here, I've got root 3, okay, and the tan of 60 degrees is equal to root 3 over 1, opposite over adjacent. So that means that my related acute angle here is 60 degrees. So my solution in my second quadrant is going to be theta equals 180 minus 60, which is 120 degrees. And then my solution in quadrant 4 is going to be theta equals 360 minus 60, which gives me a second solution of 300 degrees. So some examples that are just like the ones that we did earlier in the practice, except now we don't need to use our calculator to figure out what those related acute angles are.